Good evening. So today we are going to be with another video that is for truss. So why graphical method is preferred in truss? Because for a truss we have unique graphical solution. Means your graphical solution is independent of your loads. So if scale is changed, then your graphical solution will not change, but force in the member will be changed. So for a truss, we have unique graphical solution for same type of loading. So loading should be same. Then we have that is unique. So if forces are going to be changed, change the scale, you will get forces in the member direct multiplying by the lengths. Now, which notations are used in space diagram? So we are preparing both notations in the analysis of space diagram. When we will get closed polygon in graphical method for equilibrium structure, we will get closed polygon. Is scale for dead and live load is same for graphical method? Yes. Dead load and live load, we have actually one diagram. Single diagram we have to consider for dead and live load. We will plot for dead load, we will calculate forces for dead load, and forces for live load, we have to just multiply that forces due to dead load by the ratio live load into dead load. So these ratio we are going to use to find the forces in member due to live load. Uh, so forces in member due to live load is this ratio live load upon dead load into force due to dead load. Then plotting of this vector diagram. So we have actually these are our forces. Then you can see this. We are going to be with this, that is Bose notation. Generally, small letters are going to be used outside the truss to name the spaces, and inside we are preferring that numbers. And then by this we are going to draw a space diagram. Then we are going to consider the scale, and by considering scale, so here we have considered 1 centimeter equal to 1.01 kilonewton. So generally we are going to use, if load is less, that is uh, our load that is on end panel point. Then we can have this, you can see this, we are going to plot first these all loads. So till I, J, K and L. Now till this we are, and now we will plot reaction which are in upward direction. So you can see this M, and then we have this as A. So this is my closed polygon. So structure is in equilibrium, and then we will plot it. So this we have plotted. Now we are going to mark, we are going to find point 1. So we have B, we know, so we will plot line parallel to B1. We will plot line parallel to M1. And intersection of this gives me point 1. Then we can have that is 2 point. How we will plot? Now we know 1. So we will plot parallel to C2. We will plot parallel to 1, 2. And then intersection of this gives me point 2. Similarly, we can find 2, 3 and M3. So likewise, we are in position to plot these all values, and then we can find the forces in members. How we will find forces in members? Then if I have to find force in this member, then I have to measure B1. So we have 1 over here, B over there. So I will measure this length, and I will multiply this length by my scale, that is 1.01, gives me force in the member. Suppose I have to find that is 7 8, this vertical. Then I will measure 7 8 length. I will measure this length. I will multiply it by 1.01, gives me force in this member. So likewise, we have to find forces in the members. Now, how to decide its nature? Then let us, I will consider this joint. So if I will draw this joint, then you can see which are the members and which are the forces. So we have this as 2.02. Then we have this space, that is C. We have this space D. Then which members we have over here? So we have one member like this. We have another member that is vertical. So we have given this space as 2. This space we have 3. This space we have 4. And then we have to go clockwise. So now we have D4. So we have D over here, and 4 we have here. So we have to travel D to 4, which is in downward direction. Then I will mark in downward direction. As it is towards the joint, so we have compression in the force. Now 4 to 3. Now we have 4 to 3. So we have to go in upward direction. So if I will go in upward direction, again towards the joints of compression, then 3 to 2. So 3 we have here, 2 here we have. We are going in downward direction. So 3 to 2, we will go in downward direction. So away from the joint, we have tension. Then 2 to C. 2 we have here. C we have the upward. So C to 2, we are going upward. So show it upward. Then here also we have compression. So likewise, you have to find the nature. Suppose I will consider this joint. Then what are the forces in this? So we have like this. So one, two, three, four members. So we have this as seven. This is six. This is five, and this is M. Then again we have to go clockwise. So we will go five to six. Then we have five, five to six. Then we have downward. So 5 to 6, we have downward. So force in this member, we have compression. Then we have 6 to 7. 6 we have here, 7 we have there. So 6 to 7, we have to go upward. So we have to go upward. We have tension in this one. Then 7 to M. 7 we have here, M we have here. So we have to go in this direction towards right. So towards right, away from the joint. So we have tension. Then we have M5. So M we have over here. 5 we have over here. So we will go M to 5 towards left. Then I will have M to 5 towards left. Then we have tension over it. So likewise, we have to decide the nature of the force in the member by considering each joint separately in case of your graphical method. Then we have same vector diagram you can see for wind load. So we can have this will be our external forces. So that is 4.3, 8.6, 8.6. Here my scale is 1 centimeter equal to 4.3 kilonewton. Likewise, you have to consider it. And now I will plot reaction. Now this reaction is in downward direction, LM. And then we have this will be LM in downward direction. And then we have MA. This is again in downward direction, again in downward. So this is again we have closed polygon, and as it is closed polygon, that means my truss is in equilibrium condition. And then we have to plot it. This is parallel to B1. So B1 parallel. Then 1, 2 parallel we will plot it. So we have M1 we have, and then M1 that will gives me zero point 0.1. So this is zero point 0.1. Then plot parallel to 1, 2, and then C2. So this will gives you zero point 0.2. So likewise, we have to go then multiply, measure the length, multiply it by scale, that is 4.3 kilonewton. You will get forces in the members. Now you can see this is always symmetrical. We have these 8 and 11. We are at equal distance because we have 8 over here, we have 11 over here. 9, 10. Again, we are at same point. Why 9, 10 are at same point? Because we have force in this member is 0. And as force in this member is 0, so we have 9 and 10 at same point. So 1 and 18, we have 1 over above at same distance. Now 1 and 18, we are going to be at this joint only. Sorry, this we have 1, we are going to be here, then we have 2. So now we are going to be 2, and this we have 17. Then you can see this is 2, then we have this at 17. So this point 16, then we have 3. So this is symmetrical. Then we have 16, 3, we have at this point. So likewise, we are going to get this vector diagram for this. Then what are sign conventions for dead load and wind load in graphical method? So this is away from the roof is considered as positive, and towards the roof is considered as negative. Then you will say how we have negative values. Now then CPI we have minus zero point 0.2. Minus zero point 0.2 means towards the roof. So we have these are towards the roof, which is minus zero point 0.2, which is your value of CPI for openings less than 5%. And then we have this value. Then we have to add this. So though this value is negative, this value is positive because this is away from roof. We have plus. This is towards roof. We have minus. But these two will take roof away, and therefore we have to add it. And for dead load, live load, we know that is downward is minus, upward is plus. What are the load combinations? So we have considered 1.5 dead load plus live load and zero point 0.9 dead load plus 1.5 wind load. Now generally this value we have negative, and this value we have positive. And therefore, according to IS code, if your stress is being to be reduced due to dead load, then this value will be considered as zero point 0.9. So these forces due to wind load and forces due to dead load in the members are in opposite direction, in opposite nature, and therefore we have to take it as zero point 0.9 dead load. Then for above combination, we will get two values. Then whatever maximum value we will get, for that maximum value, we will provide the section. We will design the member, and whatever section we are going to provide, we have to check it other value which we are going to say as minimum value. So for maximum value we have to design, and for minimum we have to check that provided section can satisfy it. Generally these two are in opposite nature. So these are the questions which are from your process focused on graphical methods. So we will stop here only. Thank you.